other friends just come in. Okay, right. So almost everybody is here now. So let's restart, right? So I have something called a plain text called Parvez, and I do not want my client to send this plain text on the web because people like Eve are already sitting there on the web looking for information that runs in plain text. So we do a very simple, use a very simple mechanism that we will discuss. There is something, I mean, if I just move one character away, there is a alphabet called Q, which is after P. After A, we have B. After R, what do we have? S. After V, we have W. After E, we have F. After Z, if it's a circular motion, then you have A. So now if you look at the text given below, you will find that, right? You will find that something which was at the top was a clear text. I called it a plain text. This text was read and it was understood. This fella has a username called Parvez. However, when something like this travels, the individual doesn't know what it is talking about. So this is known as an encrypted text, right? Or you call it encoded text. It is one the same. But what is important? What is very important is the key. Here we decided, in a very simplistic term, we decided that let's skip one alphabet for all the characters. So let me just say, let me, if I rewrite this, let me add 1 to a given character. Is there any doubt? Let me just note it down. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Let's skip it till this, right? Right. So when you have a self character, give it a digit called 0, because if you replace A by A, the plain text remains same, right? Am I correct? Call BS1, call CS2, call DS3, call ES4, call FS5, call GS6, call HS7, call IS8, call JS9, call KS10, right? Call LS11, and so on. Are you guys with me?
Yes.
Hello?
Yes, sir.
Okay. So everybody is clear with what I'm trying to convey? You cannot
Yes, sir.
replace. See, now if I talk about this, you cannot in any way replace P by P, because if you do this, like, understand that it's a 0 at P, right? So if you replace P by P, A by A, if you replace R by R, V by V, E by E, Z by Z, then you are going to have a plain text. Am I correct? So what I mean to say is, this algorithm says that K equal to K plus 1 is the key. When I want to encrypt something, I will add one, I will shift one character away. That's what I decided right now. I could have decided 2 characters away. I could have decided 3 characters away, and I could have decided 25 characters away. So A would be replaced by a Z, right? B would be replaced by a A. C would be replaced by a B, in case if it's a 25 character replacement thing. Now, This thought says a cipher text equals plain text plus key, wherein k equal to k plus 1. Remember this. That's it. So now, if we encrypt something at the client side, when it reaches server, you have to always decrypt it. So decrypted text equals, what do we put now? यहाँ पर हम क्या डालेंगे?
Cipher text
Cipher
minus
text,
key.
the result of plain text plus key. So when you want to decrypt, your input is cipher text minus key. Therefore, here your key, when you decrypt, you do a reverse process. Fine. Why do we do a k plus 1 and k minus 1? Because you want to come back. आपका जो प्रोसेस है उसमें आपने जब कन्वर्जन किया, when you did the conversion to cipher text, you added one character. Now you want to come back to the same plain text, so you do a k minus 1. So now if we look at this, let me do it. K plus 1. So P is replaced by Q, A by B, R is replaced by
S.
S, V is replaced by Vishwas.
Yes, sir.
Vishwas, V is
V is
replaced by
replaced by W, sir.
E is replaced by
E is replaced by
F.
F, sir.
F. And Sarfaraz, what is Z replaced by?
A.
Okay, so this is your cipher text. Now we want to come back to the plain text from the cipher text. So what will you do? Q will be replaced by P, B will be replaced by A, S will be replaced by R, W will be replaced by V, F by E, and A by Z. So you get your plain text. Are you with me?
Yes, sir.
So encryption, encryption is a process where you apply a key on the plain text in a forward direction, and decryption is a process where you apply the key in the exact reverse direction. You cannot do a k plus 1 for this particular algorithm while you decrypt, while you decode, because if you do that, then it's a problem, right? So let me just show you. Let me check. Okay. Let me come here and say CAESAR Cipher. Right? Let's see how CAESAR Cipher is. If you come, I mean, is my screen visible to you all?
Yes, sir.
Yes, sir. Yes, sir.
Now, see, this is a cipher wheel. If you look at, if you consider these as a plain text, right? What do you see here? Plain text to cipher text. K equals 19. That means K equals K plus 19. What is your K? A. When you do a plus 19 to A, what do you have? Just check with your hands. Just see. Is it T? A is 0, B is 1, C is 2, The 3,
Yes, it's
4,
19,
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So A will always be replaced by D. When K is equal to 19, if K equal to 3, A is 0, B is 1, C is 2, D is 3. So A will get replaced by D. If K is 6, B is 1, C is 2, D is 3, E is 4, F is 5, A will be replaced by a G. If K is 0, you cannot replace the same text again, because if that happens for this particular algorithm, then you are nowhere, because nothing gets encrypted. Your alphabet is replaced by self. Therefore, that's not feasible. This algorithm is one of the most classic encryption algorithm. It is known as a classical algorithm. So what is a classical mechanism? Any idea? Classical mechanisms are those mechanisms that have been employed initially while this work was in progress some time back or a long back, and now they have not remained relevant. ये चीजें relevant नहीं है. However, people still look at these classical algorithms for the sake of simplicity, for the sake of brevity. You have to remember this. Right? So, is there any doubt that you have in your mind before we move ahead or before we discuss things?
sir. Like a brute
Look
forcing,
at
is there any
that.
tool which is doing like वो जो ये सब जो algorithms है उसको जानता है और उसको क्रैक कर सकता हो?
हाँ, हो सकता है. Always possible. People try to even for that. My answer is, first you should know what kind of algorithm that is. Like, I haven't discussed anything about that. So what I am trying to now tell you is, this cipher is known as a stream cipher. What it is called? It's called a stream cipher because a character is replaced by another character. Okay, first thing. And before I call it a stream cipher, I'll call it a symmetric encryption. I did not use these words because I wanted you people to understand things first and then look at the buzzwords. इसको क्या बोलते हैं? Symmetric encryption कहते हैं. Why symmetric? To encrypt, you did k plus 1 for. So now to decrypt, you do a k minus 1 so you come back. So in algorithms को बोलते हैं symmetric algorithms, और symmetric का एक part है stream cipher, wherein each character every time will be replaced by one character, another character. ठीक है ना? तो ये 1 by 1, byte by byte encryption हो रहा है. Therefore it's called a stream cipher. The next class that, I mean not next class, but sometime later we will study something called block ciphers. So within stream there will be many algorithms. I mean few algorithms that we will discuss. And then we will move to block ciphers. Important. There is an algorithm which is called DES, Data Encryption Standard. There is another one which is called Advanced Encryption Standard. आप in words पे थोड़ा गौर करिएगा. Right? This is by known as DES, And this is no an improved version of DES is an AES. Right? So now I come back to your question. I mean, who asked the question? Can someone just repeat the question?
सर तो क्वेश्चन ये था कि जैसे कि ब्रूट फोर्स के ऐसा टूल आते हैं, तो ये जो एन्क्रिप्शन के एल्गोरिथम्स है उसको ब्रेक करने का कोई टूल है या वो बन सकता है?
टूल बना सकते हैं जो पर्टिकुलर एल्गोरिथम को ब्रेक कर पाए। उसके लिए भी आपको एक चीज याद रखना पड़ेगा। What you need to remember. See, the symmetric algorithms that are being used, that are being deployed, are not proprietary algorithms. Most of the algorithms being used are already available in public domain. तो उस एल्गोरिदम को तोड़ने के अलग अलग रास्ते, ब्रेक डाउन करने के अलग अलग अटैक्स जो हैं, वो इधर टू फाइंड सम प्रॉब्लम इन द एल्गोरिदम, और through an attack you try to break it down. Either find the key without having the key, either find a key with a minimal information about the key, either take the key from some other location within the text. These are ways and means to do that. So it is always possible for people to find a problem with the algorithm, break it down, and identify the key. See, you have to remember, nowhere the algorithm is important. In the algorithm, what is very important is the key. See, I'll take up a very simple analogy, right? If you can relate to that, I think things should be more clearer to you. We usually hear, right, there is a 7-lever lock. Have you heard? आपने सुना है 7 लीवर का लॉक होता है? और I mean, which are the places that manufacture best locks? कोई नाम सुना है जो बहुत बढ़िया लॉक होता है, जहां का लॉक है वो एकदम स्टैंडर्ड होता है? ऐसा सुना है कभी आपने? एनीवन? नहीं सुना? यू कैन ऑलवेज से नो, राइट?
नो सर।
देयर इज अ प्लेस कॉल्ड अलीगढ़। हमेशा कहते अलीगढ़ ना ताड़ा, locks from Aligarh, right? Or there is a lock, like Godrej has a 7-lever lock, or probably a bank has a tijori, if you remember. There is a huge safe, SAFE, and in that safe there is a combinatrix lock, a lock which has a lot of combinations. So what is important in the lock? It is not the lock. What is very important is the key. Can an adversary do something wherein without the key, can the adversary unlock the ciphertext into plain text? If he is able to do it some way, either finding a problem in the algorithm or having some partial information about the key or something else, that means the job is done. So in computer science, remember, there is no security which is 100% security. Nothing is 100% secure. It's not possible. आप लोग देखते होंगे, companies usually provide an uptime which is a 99% uptime, 99.4% uptime. Why they never say 99.9999 or 100% secure? It is not possible. Remember, security is a game of cat and mouse. I'm only talking about reactive security. In security, we have to remember that someone who has to guard the product, take care of the product, is a defender. ठीक है? Defender has to remain vigilant all the time. There is no way that an individual can remain unguarded. Never possible. However, an adversary always needs just one chance to get inside. So you have to remember, अगर हम बात कर रहे हैं सिमेट्रिक एल्गोरिथम्स की, तो सिमेट्रिक में दो टाइप्स हैं. देयर आर टू टाइप्स. वन इज द स्ट्रीम साइफर, where each character is replaced by another character which converts a plain text to ciphertext. Whereas in a block cipher, a group of alphabets known as a string, a group of 8 or a group of 16 or a group of 12, which is known as a block of characters, is encrypted. We are not going much into that, but you have to remember that there is nothing which is 100% secure, because in computer science there is nothing which is 100%, right? An adversary always stands a chance to break something down. Are you guys with me?
Yes, sir.
Yes, sir.
Yes, sir.
So if you have a question, you can always ask. I don't want to continue beyond this topic right now, but I want you people to understand and then probably dwell on this. I started with the CAESAR Cipher yesterday. I again very thoughtfully explained this particular algorithm, nothing else, with important terminologies, right? But this is how the algorithms will work. Every stream cipher will have a key, not just a stream cipher. Important. Okay. The key that we have is a confidential key. So these algorithms are also known as private key algorithms. कैसे क्या बोलते हैं हम इनको? We also call them as private key algorithms. या हम बोलते हैं confidential key. If you lock your house, what do? Do you take your key along with you, or you put the copy of the key under the plant? अब क्या करते हैं जब आप घर को लॉक करते हैं जिसमें बहुत सारा सामान पड़ा हुआ है, इंपॉर्टेंट चीजें पड़ी हुई हैं, तो व्हाट डू यू डू? एनी आइडिया? Is it safe to keep the key somewhere for someone else to pick up?
No,
Or
no.
you wouldn't do that? Right? If you do that, then it's a foolish idea. It's a bad thought. आपने लॉक तो लगाया लेकिन चाबी भी वहीं रखी है. So if you remember, all of you use ATMs and credit cards.
Yes.
Yes.
So when you use your ATM, someone will ask you to enter your PIN, right? Right?
Yes.
When your credit card is swiped, when your debit card is swiped in the ATM, it asks for a PIN, right? Do you
Yes.
write down your PIN on the card or you remember it?
I remember.
Remember.
Why don't you write down on the card itself? What's the reason you don't write it on the card?
कार्ड गुम हो जाएगा तो पिन से कोई भी एक्सेस कर पाएगा.
Right. So your PIN is your key. So the way we don't part away with our key. Similarly, even here, we never part away with the key. But remember, this is a confidential information exchange between two people. So two parties. The party sending the information, that is the client, is known as a sender. What is he known as?
Sender.
Sender. And someone who receives the information, the server, is the receiver. So the sender, when he locks the plain text, he applies the key in forward direction. Up, whenever you lock your, when you lock your lock, or when you lock your house, that lock is in the cyclic direction, in the anti-clockwise, in the clockwise direction, if you see. And when you unlock, it's exactly in the reverse direction. Just check it out. Right? Because when you lock, your direction, say, is a clockwise direction, then when you unlock, it always should be an anti-clockwise thing. Therefore, when we encrypted, k equals k plus 1. When we decrypted, k equals k minus 1. Also remember, in encryption, decryption, what is very important is the authenticity of the algorithm, the strength of the algorithm, and the key. Because if you write down your smartphone password or your device password behind in the cover with a cheat, and if someone gets hold of your smartphone, he has to do nothing. He will just identify a few things around and he'll see, oh, there is a number written, let me try. So he will try that number and the lock would just open. So he made no effort. Actually, you made effort on his behalf. You made effort on Eve's behalf to help her out decrypt the content. Right? So what we discussed today, is everything clear, or there is some doubt? Because we are reaching somewhere around 9 minutes towards the end of our second session. If you have doubt, come up with the doubt, no problem.
All clear, sir.
Yeah?
Everything is clear.
Someone? Everything is clear? So
Yes.
now you have to understand, we'll discuss a couple of more stream ciphers. Why I said stream? Because it's a character by character encryption. Therefore, it's a stream cipher. पानी जैसे नल में आता है, वैसे स्ट्रीम की तरह है. एक के पीछे एक चीज आती है, तो वो स्ट्रीम है. If something happens at a time, it will be a block. I have also not shared one information, which I am sharing now. There are two broad categories of encryption mechanisms. One is called symmetric, and second one is called asymmetric. Right now, we are talking about this. We are talking about this. See, plain text is encrypted via something which is called a secret key. And it is compulsory that the sender and receiver share the same key. Sender और receiver के पास एक ही होना चाहिए. Assume that the sender is hundreds of kilometers away from the receiver. आप Gmail यूज कर रहे हैं और आपका जीमेल का सर्वर जो है वो यूएस में है. When you are logging in, your server is in US. So now I think you should be able to relate things. All right. Same key दोनों के पास है. Sender encrypts and receiver decrypts. Now if receiver encrypts, sender will decrypt. If sender will encrypt, receiver will decrypt. If this communication keeps going on, this process will continuously go on until both of them do their own task. I am not discussing any further issue with symmetric encryption. There is something else which is called asymmetric. The only difference is an A, nothing else. See, symmetric. If you go on top, is there any change? Just an A. An algorithm which is not symmetric is asymmetric. At the top, you guys saw just one key. Is everyone there?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
All right. And if you see here, there are two keys. Can you see that? A difference. Public key is known to everybody, therefore it's called public. And private key is only known to you. But there are mathematical functions which, if used properly, for a corresponding public key, you can generate a private key. For a given private key, right, you can do something else. And you remember, public means everybody knows. It is in knowledge of everyone. And private means it is you who only knows, no one else. आपके सिवा कोई भी नहीं जानता है. That key is a private key. And something which is known to everyone is a public key. Right now, we stop here. We stop our session at this point, and probably in the next session, we'll try and continue with some more symmetric key encryption algorithms, and then try and compare. Right now, someone asked a question. Can we have a tool that can break an algorithm? Of course, yes. Find the problem with the algorithm. If you find the problem with the algorithm, exploit it. If you are able to successfully exploit it, demonstrate it. If you demonstrate it, everybody will know this algorithm is unsafe to use. But remember, never share your key with somebody. Last question before we part. Do you ever share your email, social media, or banking password with someone? Do you do
No,
that?
sir.
Not at all, sir.
No.
No? Why no?
No.
Because through it they can access our, like they can use our identity.
So that means that's your private attribute. And when it's a private attribute, it's dangerous to share. Therefore it's private, no? Something which is private remains private up to you or with you only. No one else except you should have access to what you have. I think what I said should be fairly clear to all of you. All right.
Yes, sir.
So I think we have some couple of minutes left before this session will automatically get closed. But still, if there is any doubt, if not doubt, if you have a question that you think you haven't asked me before our meeting winds up, I think you can.
Sir, I
And
have a
I,
question.
yeah, make it fast. Yeah.
सर, आपने बोला मल्टीपल यूजर से और सिंगल सर्वर होता है,
हाँ जी।
तो जो डेटा ट्रांसफर होता है वो सभी यूजर के लिए सेम की में ट्रांसफर होता है?
नहीं होता है, हर बार अलग होता है। आपके घर में 5 ताले हैं तो हर एक की चाबी होगी ना। You cannot have a
यस,
common key. So if
यस
there are
यस।
1000 users, there will be 1000 sessions. One
ओके
session between user 1 and server, second session between user 2 and server, and 1000th session between 1000 number user and server. Server remains one until the server is able to take the load. Once the
ओके सर।
server is exhausted, once the limit is reached, the owner of the server will ensure that there is another server at a nearby location to do that. And that's what you do from India when you log into Google or to Microsoft or to Facebook or somewhere. It will always find you an Asian server. It may not take you to the longest distance to the US or to the Europe. So it's
ओ-
called distributed scenario. All right. So
ओके।
thank you very much for this wonderful discussion that we had today. We'll continue with this series of security,
Sir,
especially web security.
pass through authentication.
Yes.
સર આ જે તમે કીધું એન્ક્રિપ્શન વાળું